Okay, welcome to the April 20th Social Modeling Video Conference. Today, Kevin and I is going to continue the discussion of the structural biologic design or interpretive structural modeling playbook. And it's going to continue to review the content and areas of special concern. So with that, Kevin, take it away.
Okay, and while I introduced this, I put the playbook back on the screen, and after a minute, scroll back up to where the the colorful pyramid was. But we're going to talk about this section in here today, which are activities for conducting a structured democratic dialogue. It's also called structured dialogic design or interactive management, and it's kind of a version of interpretive structural modeling. It's had multiple names over the years, and also called the Cognoscope. So if you could scroll up, Joe, so I can provide some context for people that haven't seen this work before. In the 1970s and 80s, there was a quest to develop more serious methodologies for very large-scale projects, and there was a lot of promotion of design methods that was coming out of the United Kingdom, and also promotion of things like brainstorming that came out of the US by Osborne, and things that were promoted that were techniques or methods that could help groups be more productive. And from like the 1930s through the 70s and 80s even, there was a big interest in techniques for creativity. And brainstorming is probably the most famous, not the most effective, however. And within 6 years after brainstorming's debut, there were a number of people in the operations research community, at least that's where they tended to publish, that put the brainstorming to the test and debunked a lot of the claims of Osborne. And he was discredited, and brainstorming was discredited within the academic community and the operations research community. However, the name caught on anyway, and it became so famous, it was more famous than the actual technique. Most people don't even know the actual technique for brainstorming.
I can't use the phone.
So Warfield and Christakis and Ozbakan, we viewed about 70 techniques and tested them out to find out which ones should be considered as part of a toolkit. And they arrived from about 60 or 70 techniques. They arrived at 7 they thought were good. One, which was specifically developed to supplant brainstorming as a doctoral. It was done as a doctoral thesis, supervised by a guy named Delbecq, and it was by Van de Ven, and that became called nominal group technique. Nominal group technique was a way of doing idea generation, and it's often referred to generically that way within other methods, but they've actually adopted nominal group technique as a way to get the ideas on the table. Then something they didn't do a good job of reviewing involved clustering techniques. And there was a lot of work on clustering in the 70s and 80s, especially through the use of computers. This was a real shortfall of Warfield and Christakis. They tended to ignore all the literature on clustering. And they did do clustering, but didn't really have much of a technique for it. They presented the form and called it options fields, or options profiling with selections of things within a field. And it's a little strange that they call it options fields, because they use the same clustering technique for problems, and they would call it the options field of problems. And then how do you solve the problems? You use options and select the options to take action against the problems. And so why it didn't make sense that you had options fields of problems. So they really didn't really think out that well.
Kevin,
Yeah,
you're breaking up pretty much. We're
maybe I'm moving
of
the
your discussion. And so you were talking about the clustering technique and
Yes.
how the techniques basically were done. I think I'm just going to recap here so that it get hopefully everything on the video. But you're talking about the dimensionality, where they took and created clusters out of dimensionality out of the options field. So we're so that's basically, I think, what you're talking about. And the way that they used clustering was a little bit different than the other approaches. Is that kind of what you're saying?
Yeah, their idea was there had been a lot of effort put into developing different techniques, and they should adopt a technique rather than investing in developing new techniques. So they did this with the idea generation. They found a better technique than brainstorming. It came out maybe 16 years after brainstorming, and it was proven to be better. And that was nominal group technique. Then they used a clustering, but they didn't really adopt someone's technique. They kind of just put together their technique. And so that's open still, in my view, to adopting other more formal techniques for clustering. And then the third major area was the interpretive structural modeling, which gives you the structural understanding. And what you're seeing on the screen here is a representation of going through those three basic processes twice. So, or three times. I think at the top here, you see some work that would be done before we had a big group meeting. And then in the red, we would develop a structured understanding of problems. And then in the blue, we develop
Kevin, you're cutting out again, so
okay, let me try.
I think that's Peter, because Peter doesn't have his mute on. There you go.
well.
Okay, how's that?
Sorry. Yeah, so the
is that better?
I think that's better. That's better. I was going to just
great,
kind of recap now. It was kind of choppy, but the idea that I think what you've said so far is that the brainstorming techniques were essentially debunked. They didn't work. You came up with the idea generation technique, which generated a lot of ideas, and then once you got the nominal, once you had all of these different ideas, then you needed some kind of way to evaluate combinations of them. They did clustering, they did discussion, and so forth. So I'll turn it back over to you.
Right.
Kevin, I have a question. So
Yeah.
I came in a little bit late. So you said there were three basic techniques that were
Yeah.
used. And what was the first one?
Yeah, something for idea generation.
Idea generation. Okay, because I've been thinking of ISM as the umbrella that would cover idea generation, nominal group technique, and the getting into the form where you can use the BSM. But is ISM just part of that suite, or is it used as the umbrella term?
There in the 70s and 80s, often ISM was used to be the umbrella for everything. But in later years, and in the more dominant use in the literature is it just refers to the structuring step, the structuring portion. And the work that Joe's been presenting on basic structural modeling is just focus on the structuring step, I think. You typically use it, you typically generate ideas, and then you cluster them because you may have 100 to 300 ideas. You can only take the time to structure 10 to 50 ideas.
Right, and so you have so BSM. Excuse me. So you'd have idea generation, nominal group technique, and then BSM, or would yeah. And anyway, we don't need to get an exact partition here, but I'm still a little.
Yeah, nominal group technique is a type of, it's a technique for idea generation.
And for structuring generation, right? Or for understanding the relationships, or for getting people's opinions.
It's to get a list. Yeah, it gets a list of ideas, how people think about their ideas, cultivate some dialogue about them, and typically you generate 60 to 300 ideas using the nominal group technique. And then depending on who's publishing it, they consider voting on ideas as part of the technique.
I thought that the nominal group technique also included the identification of the relationships. Is that true?
No.
Like asking, is this related to that? Applying your
that can happen during clarification. People will say, as people in the way this technique is typically deployed, you type the idea up as someone is saying it, and it goes up on the wall. And so after everybody's ideas on the wall, say you have 100 ideas on the wall, they typically be a column of five ideas, and landscape mode, 8.5 by 11 sheet of paper, printed the 36 font, and so you're looking at 20 columns of ideas, and after everyone has said their ideas, they then would go around and briefly explain what they mean by an idea, and then someone would ask them questions to clarify it, and they may say, how's your idea different than idea 11? And then someone would draw the author would draw the distinction about the idea.
So under your term idea, does that include possible framing questions, identification of objects, and identification of relationships? How do those three elements fit under idea?
The relationships would only come up during nominal group technique in the context of a clarifying question.
Okay.
If someone said, does your idea relate somehow to some, to idea 24? Is it similar? We would tend to encourage people to ask similarity and difference questions. If they get into the causal types of relationships, linkage types of relationships, that would tend to be discouraged because it puts too much on the table.
Right. I guess, pardon my ignorance, but working backwards from the BSM perspective, what you need to come out of this front end is a relationship mapped over objects, which presumably were, and that those objects and the relationship or relationships were identified through one or more framing questions. I'm just wondering where you get to saying these are the objects we're interested in, and this is the relationship that we will structure. Is that in ISM, or is that still part of this idea generation and nominal group technique?
Typically, in the scenario here that you're looking at on this page, there was a framing question that happened before an event even took place, and a structuring question before the event took place that was done to get a handle on material, like trends, for example, would be a common thing. What are the trends going on in the industry? Because you can typically discover that from literature, and you don't need to put 30 people in a room for 2 days to talk about trends if there's a lot of publications about a field. So then in the months, this is like a minimum 3 months before you would do an event with 2, 3, 4 dozen people. You would cultivate a triggering question, or you could call it a framing question. The original language was triggering question. I don't like that word, but that's what you'll see. But it is a framing question. And you'll also have what's called the generic question, which is the relational question. Now, in the way that Warfield and Christakis outlined their overall approach, they would use this technique or this overall methodology to model any kinds of systems. They modeled goal structures and objective structures and curricular structures and schedule. They did scheduling and PERT. They did safety diagrams, causal diagrams. They did many different things. But what they came to focus on already by the late 80s was just problems and actions. Out of the many, many dozens of things you could see what you could deal with, what you're calling objects, they only dealt with problems and actions.
That's really interesting because we're disciplined, thanks to Joe and Mary, from thinking in the BSM sphere of objects and formal relations.
Right.
And then the big question in their recent technical report is, how do you relate the formal perspective coherently and consistently to the natural language constraints, which are this fuzzy front end? Those questions relate to the all of this that you're talking about. So I'm still, that problems and actions are such composite objects that I'm very surprised that that they're taken as being sufficiently basic that you could do BSM on them. It's interesting. I'm surprised by it.
Well, they're not trying they weren't trying to use all of the BSM.
Uh-huh.
What's outlined for all the possible math relations in the BSM is dozens of times more stuff than Warfield and Christakis just came to focus on.
Right. Except
So-
I guess it's more like it's a systematic treatment, even if once one gets through the systematic treatment of all the possibilities, one ends up focusing on just a few. At least one puts all of the possibilities on the table to make sure that they're, that you have a systematic approach. Anyway, so I guess Warfield and Christakis were driven by the pragmatics of needing to get these events together and what people were interested in, rather than the having the luxury of thinking completely about all the possibilities. It just interesting contrast. I didn't mean to divert your discussion there.
Yeah, they thought quite a bit about all the possibilities in the 70s. There was lots of unpublished materials, manuscripts, and presentations. For example, what are the relationships of interest to model?
Uh-huh.
And they had a slide, had over 60 different relationships in 6 different categories.
Right. I think you've showed us that before.
Yeah.
Right.
But they picked one,
Mhm.
or no, they picked 2. The 2 they picked, one was for the problems. They picked aggravation relationship.
Uh-huh.
So does problem A aggravate problem B? Was the typical generic question. And for actions, it was an enhancement relationship. If I do problem A, will it enhance the probability that problem B? If I accomplish action A, will it help accomplish action B?
Uh-huh.
And that gets asked with little subtle differences, and that tends to be that's all that for almost all, I would say 95% of the applications that Christakis did for the rest of his career after the 80s. That's the only 2 things he ever did.
That's very helpful. So, but I feel, and I don't know, Joe and Mary maybe are motivated by the same feeling, that one needs to revisit the questions in the 70s, because on questions of Mariology and ontology, and in order to get to the real the deeper systematic treatment of natural language and empirical relationships, you need to do the kind of questioning they were doing in the 70s. Do you know if anybody else is revisiting the 70s type explorations other than our group to some extent?
Well, I did.
And you?
Yeah,
that's what I was going to say, and you. Right.
I did in the 90s because I wanted to model, for example, I wanted to do IDEF modeling.
Right.
IDEFINE, which is a IDEF 0 primarily, which is a functional modeling technique from is it the Air Force or the Army? When it was a maybe Army manufacturing initiative, developed the IDEF language, which was big in the 80s. You don't hear about it too much anymore, but I was involved with a project where we had I don't know, a dozen people on a project to map concept to physical realization for a jet engine. And it took us 3 months to go through just to update the mapping.
Right.
The map was like, I don't know, 6 4-inch books.
Right.
And like 5,000 or 6,000 process steps.
Right.
And so I wanted to look at, when you're doing IDEF modeling, you don't get to robustly consider all the possible juxtapositions of the process steps and how they might relate to each other, which is what the quality function deployment technique was saying you had to do.
Right.
But you get above 300, for example, Ford Motor Company, Xerox, Hewlett Packard, they topped out at about 300, relationship of 300 functions. And like a car door is a 300 by 300 matrix of relationships.
Right.
And it takes a team like 6 people 3 months to do it. And they eventually were throwing up their arms and saying, "This is ridiculous. It costs so much."
Right. Well,
Just
this
to
is
do
really
that.
interesting.
And that's how Ford was just drowning in matrices.
Uh-huh.
And they said they
That
said
needs
to
to be a
this,
chapter in your autobiography, Drowning
Yeah.
in Matrices.
drowning in matrices. And they went to they had like an experimental or an advanced computer aided engineering group at Ford.
Uh-huh.
It was led by Scott Staley. And the name of Scott's computers in his lab were all named after mathematicians. He was a mechanical engineer, but he was really into math from like the turn of the 1900s, like when they were discovering prepositional logic and first order logic and that type of stuff. And so someone asked him, is there, people were telling him, the Japanese were telling them that the quality function deployment was a science of design. And this guy said to Sky, he says, is that true? Is it really meet the caliber of a science? And isn't there something we could do better? This, filling out the matrices is killing us. And that's how Staley was attending a design theory and methodology conference, which was, I think, one of the first ones. And it happened that Warfield and Christakis were making a presentation about what they were doing, and they basically had software that was filling out these matrices.
Okay.
And
how do you spell Staley?
Staley.
This historical perspective that you've done several times in presentations is so helpful, I think. Both the longer one that you give going back a couple hundred years and this, because it really helps clarify how we've gotten to where we are. Yeah. When I was developing a thesis topic for a PhD in 90, I was interested in IDEF, but what I was interested in was why is there no IDEF X? Why is there no interchange framing that will allow you to systematize the relationships among the IDEFs? And I wanted to take on these more gnarly front end issues, as well as the BSM side, the technical issues. But that it was so broad that wasn't considered it almost became a topic. I think I mentioned that Digital Equipment Corporation was interested in funding it, but then they weren't able to follow through with their problems. So, but it required addressing language, metaphysics, psychology, all of these fuzzy front end issues. But I feel like, so that's sort of what Michael and I have been working on, independently, is trying to explore all of these deeper issues that need to come in to systematize the front end. Anyway, so lots of fun to hear your recounting there. I don't know if did I interrupt your history or your flow of the presentation? Was there more you wanted to say about the history, or?
Oh, I can. What we're trying to do, alternating between the mathematical, technical work that um, Joe and Mary are presenting with this, is to have kind of an oral history. It's
Mhm.
some, it's something I felt after a lot of years of uh, trying to keep or cultivate our community of practice. I felt something that was really needed was more oral histories and more dialogue about the practice,
Right.
because we
Right.
tend to get into technical discussions and mostly deal with the unit of exchange as a technical paper,
Right.
and so we kind of missed the community building aspect. So no,
Right.
I
And
welcome
right.
an opportunity to
Mhm.
hear how what you're doing intersected with this, or how we
Right.
both had an interest in IDEF in the early 90s.
Right. Right. I think that what happened was they got to a certain point where they had to go deeper in order to, in order to complete the project. It turned out to be, in order to make it like a front end that could be used for anything, they had to uh, tackle these really profound questions that have been that people have been struggling with for thousands of years. And there wasn't really any funding source that was interested in taking that on. And it was, so because of that, we continue to do partial, local treatments, but there isn't really any, I've for years I've tried to get people interested in the idea of a grand challenge. There really should be a national grand challenge for developing an IDEF-X. That the ability to really have systematic treatment of these front end issues that leads you into the math and back out again, would require a Manhattan Project. It has to be seen as a priority to really get these things straightened out. And I see Jack has joined us, and Jack's, I think it's true that for Jack's framing, in order to support that with computer-aided whole systems modeling support, with automating what you can in order to reduce the cognitive load, that takes a lot of deep thinking and deep dialogue and development. To take things beyond a craft level has a lot of both cultural and technical challenges.
Yeah. So, I mean, one of the things uh, about doing that type of work is you have to recognize how much becomes invested in the data, right? So, and the careers. So, for example, in my company, IDEF was done by a tiny team of IDEF experts, and they didn't really think much about what the boxes meant and what the arrows meant. What they were experts on is, they would talk to someone and they'd say, oh, that sounds like D.3.3.3.7.9.5.4 process, right? And that's how deep it went. I mean,
Right.
7, 8, 9 digits deep.
Right.
Each dot was a sub outline in the
Right.
process, and that's what these guys did. They had done it for 30 years or something,
Right.
and that's and their career was being the memory base of that document, basically knowing how to file something new into the book. That was that was their expertise. That's all they worried about. And if you try to say, okay, now you're going to use IDEF 1X or IDEF2, or I saw a company down in Texas that came up with all the way up to IDEF12,
Right.
something like that. And you know, this guy just spent 30 years on IDEF0, his whole life. You know, his whole
Right.
career was IDEF0, and these were the two guys. And so the cost of introducing a new thing is low compared to how much it costs to get people to use it or
Right.
transition. You know,
Right.
they don't people don't move easily, and this is a mistake that Christakis and Warfield made. Right, by coming up, Warfield came. He didn't even work on actions. Warfield only worked on problematiques for the rest of his career after the late 80s. I don't think he ever did something besides a problematique. And a problematique is the nodes, it's a graph structure where the nodes are problems or challenges, and the arrows are aggravation. Aggravates. Problem A aggravates problem B, and you build up a network. Now, this is an interesting idea, and he felt that he took the word problematique from a French geologist, Lavoisier, not Lavoisier, maybe it was him, Lavoisier, I'm not sure. But it's a term from the 1700s, and the way the way the French thought of science and before the scientific revolution or in the midst of the scientific revolution. And the idea was to have a view of kind of the field of everything that's going on in a situation. That was the idea. It's kind of a fuzzy idea. And and it meant that when Hassan Özbakan proposed that as what the Club of Rome should do before the Limits to Growth book from Donella Meadows. This was supposed to be the project before the MIT group went and did the Limits to Growth studies. They actually got the money that was supposed to go to Özbakan and Warfield and Christakis. And anyway, so they had the guys that were doing the award in the Club of Rome just thought the problematique, they liked it. It was presented by Özbakan, who was not a technical guy. He was an economist, but he taught ethics at graduate school. He was the son of a diplomat. He spoke 5 languages. He's a real abstract kind of guy. But he also wrote the generalized theory of planning, which is it's a doctrinal reference of the military in the United States. That particular book that he wrote, Generalized Theory of Planning. I mean, the guy was, had a lot of dimensions to him, and that dimensionality kind of scared the Club of Rome out of sponsoring them.
But that's, of course, what was needed, right?
And then, so years later, couple decades later, Warfield took that notion of the problematique and he adopted the name to mean specifically a graph structure with problems on the nodes and aggravates on the arrows, which was, an insult to what the original meaning of the problematique was. But the thing I'm saying that Warfield and Christakis kind of, I think, made him the same mistake over and over and over again is, interpretive structural modeling and even more broadly, the basic structural modeling that Joe's developing now. It can be used to model an incredible array of objects and relationships,
Mhm.
right?
Mhm.
But out in the world, there's all these different modeling techniques that have millions and millions of dollars and decades of careers invested in the particular formulisms.
Right.
And these, interpretive structural modeling, basic structural modeling can be used to generate those formulisms. But if you look at the whole history of publications of Warfield and Christakis, they keep trying to do their own thing
Right.
that no one's ever heard of. Who's ever heard of a problematique?
Right. Well, this is where the autom having a computer aided conceptualization should cut through the surface differences and say what's similar and different about methods, or what's similar and different about terminology, and or because and like my idea of IDFX was that each viewpoint should be retained rather than replaced, but retained for what it's useful for. Each method should be retained, so that there is no starting from scratch. There's only elaboration of a bigger picture with multiple viewpoints, and you need computer aided support to do that on a deep level. To say there are only so many steps that we go through in trying to figure out informed action. We identify our situation. We identify possible problem components and try to understand how they're affecting each other, and blah blah. But I get that needs to be sort of a lesson from what you're saying, is that needs to be hidden. The varieties of different ways of doing that needs to be hidden from the user, so that they're not I they're not overwhelmed by the complexity of all these different techniques. Yeah, so it's lots of problems with reinventing the wheel, not invented here, that kind of stuff. But there are deep themes that keep recurring, and deep structures that keep recurring. Anyway.
Yeah. Well, take action planning, right? Sounds innocuous enough, right? Action planning, which is in the blue in the diagram that was up there. Now, who has a defined formalism for action planning? Warfield and Christakis do, but other people use it in a pretty loose way. The closest formalism that became accepted as a language was PERT charts. Project evaluation and review technique created by Lockheed, I think, Lockheed or NASA back in the early 60s. Right?
Nuclear Navy.
Huh?
Nuclear Navy.
Oh,
Yeah.
okay.
Yeah, the Navy. Navy.
So they wanted to do, they were doing bigger projects than they had ever done before by the early 60s. And so they came up with this formalism, and it's pretty straightforward. You have activities or processes, sub-projects, and precedent. Something happens before something else. It's pretty straightforward. The whole industry of software companies all built tools for modeling PERT diagrams and then doing calculations from them, like critical path method. And so that got done in the early 60s, and here comes Warfield by 73 or so. He has software that is going to cut the time to develop these large scale project models by 70%. He can cut the time, right? And do it in a more robust way by juxtaposing things you might not have thought of putting together. Can improve the quality, is what they later found out with the quality function deployment. But what does Warfield do? Instead of positioning himself to have a tool that everyone using PERT will benefit from, and all the software companies that have created their own tool will license it. Instead, he adopts the position, PERT's not sophisticated enough. I have a PERT that has AND gates and OR gates at each node. My technique's more sophisticated, and I call mine delta charts. Now, who's ever heard of a delta chart? Even people that follow Warfield and Christakis have never heard of a delta chart, right? But that's what he did, and he shot himself in the foot. Because PERT was the language. And they wanted it, so a million people speak this language called PERT. And Warfield came in and said, I have this language called Delta. Use mine, use mine, use mine. Nobody used it.
Right.
No one ever adopted it.
Right.
And they did that again and again they had model management by objectives became a big thing in the 70s. Right? They had a great way of modeling hierarchies of objectives, but they wanted to do it their own way.
Right.
They wanted their own twist on it. Now, part of that could be, it might not be just their personality. It could be that that's what publishing in a journal pushed them to.
Right.
Because you don't get to, you don't get into the top tier journals if you're repeating something.
Right. Right.
So you have to have your own twist on it.
Right.
And I think that could have been a big problem with interactive management and interpretive structural modeling.
Right. And and also, so academia is not set up to reward the kind of integrative work that has always been needed. And so if what you do is you take something and you do a slight improvement on it, or you take two things and juxtapose them and show how they're relatable, that's not rewarded, as you're saying. So there hasn't been any incentive structure for people to integrate, except in certain projects that get the national attention as critical security issues. And of course, we know that failures of as Jack keeps talking about, the failures of engineering projects can be traced to communication issues, failure to conceptualize, things that Warfield was trying to address. But there is no, there's no sense of national urgency. It really annoys me when you look at grand challenges that they say very specific things like, I don't know, world hunger, or, electronic medical records or something like that, instead of the central issues of failures to integrate and interoperate, right? Yeah, a grand challenge on interoperation. To some extent, what you're phrasing there could be, an interoperation failure between PERT or MBO and their innovations. That so the integrators need to integrate. Anyway.
I suggest that you're confusing a couple of points. That specifically, PERT is the opposite of CPM. PERT starts at the right hand, successful project, and works backwards to identify the obstacles that must be overcome in order to achieve that next state. And so it abduces the problem from right to left. Unfortunately, the engineering academia couldn't mentally accommodate that. So they invented CPM, which starts at the left and stacks hypothesis on top of hypothesis until they get to what they think is the end. Warfield interactive management overall method includes the interpretive structural modeling to identify the precedences that must exist in order to arrive at a goal. And it is, in fact, action. It is a method, not the only, but a method of arriving at action options. In too many cases, engineering people, and particularly when Ivar Jakobsen misdirected 1 million software people with use cases, they start with the presumption of what needs to be created, and they work from left to right. Procedural programming, for example. A stark contrast, which was very successful, was done in the late 80s and early 90s using Smalltalk to do object technology models. And the great thing about that was that when we expressed the model in Smalltalk objects, we could emulate the model to see its behavior, its temporal behavior. IDF 5 tried to get at the temporal aspect of a model, and they stalled out 40 years ago. But with Smalltalk, when you describe what you're envisioning in the form of little objects, then the objects can inspect one another and they can decide the best way to organize. This was automated with a tool called RDD100 in the late 80s, early 90s. And then the venture at a place called Ascent Logic in San Jose. And then the venture capitalists got in the middle of it and wanted to dump $20 million in to get in the marketplace, even though they were very clearly told that the company wasn't ready to go to market. It did not have sufficient understanding of its own product. So they got rid of the guy that was telling them that and blew $25 million and sold the company for scrap. Unfortunately, they sold it to the Japanese, which kept it relieved the Japanese from having to steal the patents anyway. So anyway, the point of it is that we are today still in this mode of procedural programming, of planning left to right instead of abducing from right to left. the military years ago adopted a technique called the order of battle. If we're going to go to war with somebody, what kind of thing are we going to attack first? And then second, and then third, etc. And of course, in the modern day, the first thing you attack is the communication network. Because if your opponents can't communicate with one another, they're at a somewhat of a disadvantage. The second thing,
I'd just like to note that we're getting about 5 minutes to the end here, folks.
okay. The second thing you attack is their supply line. And when you go back through history, all large armies were finally defeated by the opponent who was smart enough to cut off their supply line, including Napoleon. So the point of it is that when we approach this systems problem, and particularly the modeling of systems, we have to model the chronology of the system right down to the microsecond. And when you create a model with procedural thinking, it won't execute. So then you have to go in the next room and build a simulation of the thing that you modeled in order to understand how it's going to behave. But you have no way of confirming that the simulation accurately reflects the model that you have over here in this room. But when you use object technology, you use objects to model the system, and then they execute directly. You can emulate the model. And this requires a departure from engineering thinking.
But Jack, there's no scheduling and behaviors within the goal breakdown that you're talking about from right to left, goals and obstacles. And so that managing the way the demands of the different perspectives and how they interact, I think that's problematic, because you do need to go from right to left should be the priority, and that should be the grounding. But left to right is also important, and then you need to go iteratively back and forth and have some way of having computer supported, coherent consistency throughout. Well, that's my view.
Sorry, but I think you let your hands leave your arms when you said some way of doing it. If you don't have a way of doing it, then the way you're modeling is not useful.
This is a very, very important area, and it's something that I think, just to kind of summarize some of the points that have been brought up. One is the idea of where does ISM and where does BSM play. Really, what we're trying to do with these techniques is to add more artifacts and more constructs to them, like the abstract relation type and the augmented, so the
the AMEI, right?
Yeah, the AMEI, the augmented model isomorphism. That those two artifacts, concepts, allow us to look at informal language a little more formally. Maybe not formally enough, but allows us to add some more parameters to them. So we'll look at that, talk about that a little bit more on May 4th. And all these comments, I think, are really good. And hopefully we'll be able to figure out the next step that adds the most value, because we've been working on now putting the augmented interactive management software piece together. Hopefully by May 4th, I'll have some code up on GitLab. We can start talking about, I want to break those down into functions, into modular functions, so that we can talk about which is most important, which is going to happen first. And really what we've been focusing on, Janet, in most of our work is just the structural modeling piece, because that was the thing that I felt was the most poorly defined as far as the software, and that's where you need the software. And then we're going to add other software support in the other steps, and then that'll hopefully become more obvious as we go forward. So with that, I think we'll sign off until May 4th, unless there's any other burning final questions or comments. Well, everyone have a happy Easter.
Thank you for all of it.
Ah,
Thank you.
Thank you, Kevin. We still need to get back to your playbook.
That was a rich discussion anyway.
Yes,
All
indeed.
right.
Thank you. All right.
Bye-bye.
Bye now.
Bye bye.